Next, we'll see some results, that is Fourier transform of f convolution g, that is equal to Fourier transform of f into Fourier transform of g. That is Fourier transform of convolution of two function is equal to Fourier transform of first function into Fourier transform of the second function. F of f star g is equal to f of g. Fourier transform of impulse response h of t. Impulse response means output, impulse output. H of t is defined by h of w, which is equal to minus integral to plus integral integral minus infinite to plus infinite h of t e power I omega t dt, right? The Fourier transform of h of minus tau is the conjugate of h of omega, right? Fourier transform of h of minus tau, which is equal to h star omega, right? Next, h of omega into h star of omega, which is equal to modulus h of omega square. H star is nothing but the conjugate of h. You know the conjugate, right? 1 plus I, conjugate of 1 plus I is 1 minus I. Replace the sign of the imaginary part. Power spectral density of the system response output. Theorem, fundamental theory of the power spectrum of the output process in a linear system. So we'll see the statement, right? If y of t is the output process, when an input process x of t is applied to an LTI system, right, linear time invariant system with impulse response h of t, then the power spectral density of y of t is given by SYY of omega, which is equal to h omega square SXX of omega, where SXX of omega is the power spectral density of x of t and h of omega is the system transfer function. We'll see the proof. We know that Rxy of tau, which is equal to Rxx of tau star h of tau. That is equation number 1. And Ryy of tau, which is equal to Rxy of tau star h of minus tau. That is equation number 2. Taking the Fourier transform on both sides of 1. So Fourier transform of Rxy of tau, which is equal to Fourier transform of Rxx of tau star h of tau. So using the convolution idea, so we are splitting that Fourier transform of first one Rxx of tau into Fourier transform of second one h of tau. So this implies Sxy of omega, which is equal to Sxx of omega into h of omega. That is equation number 1. Fourier transform of autocorrelation. R is nothing but S, right? Power spectral. Taking Fourier transform of both sides of the second. Now f of Ryy of tau, which is equal to f of Rxy of tau star h of minus tau. So f of Rxy tau into f of h of minus tau. So Syy of omega, which is equal to Sxy of omega into h star omega. That is equation number 4. Using 3 and 4. So Syy of omega, which is equal to Sxx of omega into h of omega into h star omega. We are replacing Sxy of omega in third equation, right, by Sxx of omega into h omega in the fourth equation. So you will get is equal to Sxx of omega. H star is nothing but modulus h omega square. Therefore Syy of omega, which is equal to Sxx of omega into h omega square. Next, the average power in the system's response. The average power in the system response is given by Pyy, which is equal to 1 by 2 pi integral minus infinite to plus infinite Sxx of omega modulus h omega square d omega. Next, cross power density spectrum of input and output. The result prove that Syx of omega, which is equal to Sx omega into h minus omega. We know that Ryx tau, which is equal to Rxx tau star h of minus tau. taking Fourier transform on both sides, we will get a Fourier transform of r yy of x tau, which is equal to Fourier transform of r xx tau star h minus tau. So Fourier transform of r xx tau into Fourier transform of h of minus tau. That is syx of omega, which is equal to sxx of omega into h star omega, right? That is what we need to prove. Okay, we'll see in the next video.